presentation.
Thank you, Darryl. Good afternoon. My name is Sean Voba. I'm a program manager in the Windows Server and System Center organization. And today with me, I have Ningyu He, who is a software developer for test in the core operating system group. He is joining me to talk about some of the work that we are developing today for the near future release of Windows. So the talk that we are sharing with you today is not under NDA. However, we want to make sure you understand that this is current work in progress, and some of this may not come out all at the same time. And it is going to be present and maybe rolled out in some wave fashion. And the title for our portion of the talk this afternoon is the multi-system controlled lab evaluation tests. This is the description that we are using to describe a focused approach for a number of tests and methodologies we are developing for not only just storage, but also a number of complex solution level type of products. And I will go through some of those an example in the talk. And the second half of our talk, Ningyu is going to show you, again, a mock-up, not a mock-up, but a prototype, a work in development, a work in progress prototype as we are evolving some of the tools that you are already familiar with, but this is for the next release of Windows and Windows Server. So before we start, let me ask for a show of hand. How many of you are familiar with the Windows Hardware Certification Kit, or WHCK? I see the lip there. Any of you here are working with your test organization, your tester, as far as certifying your connected storage devices, whether the device is SAN or a NAS, mostly SAN today? No? Maybe? So let me give you a 3-minute or maybe about a 2-minute description of WHCK. WHCK is a freely available certification toolkit that has been released for a few years now. And for each release of Windows and Windows Server, we are creating and we are releasing a companion version of this kit. What this kit does is it allows our partners and vendors in general in the ecosystem to certify their product to be compatible with that particular release of Windows, to ensure that their hardware works with that version of Windows in the best manner that we could, in terms of compatibility, in terms of performance, in the sense of being able to understand how your product would perform against Windows. Now, if you were a tester, the way you would set up WHCK in your test lab is a number of different scenarios. If your device happens to be a hard drive, the setup is fairly simple. You connect the hard drive into your system, you run the test. That's about it. However, if your device, your product, happens to be a connected storage device, such as a fiber channel SAN storage array, then the setup is a little bit more complicated. If your product is a server system, it is also fairly complicated to set up. And one of the goals for WHCK is to simplify the process of setting up and of running the test against the target device, the target system, the target product, so that the tester does not have to possess a great deal of in-depth knowledge about the target device in order to perform the test run. And some of these tests, they take a fairly long time to complete, but one of the advantages of running these tests is that it can be performed with personnel with lesser skills than the architect, the developers, those who are designing the products. And it can even be outsourced to people who have very little technical insight into how the products work. So with WHCK, it is the tool and the methodology that is built into that tool we provide for free to the ecosystem for testing a wide variety of products. So if you were a tester, this is how you would go about setting it up. And if you were certifying a system, a server, you would install the kit, the WHCK controller on the test system. And this is where the tester actually performs the testing from. And you would then install the client kit onto the target. This is the system, the device that you are certifying. Okay. And as part of the testing, you would need a third system, which is acting like a test director. And finally, you would need a series of systems, additional systems, that would play the role of the test actors. So these terminologies, these roles, I would want to go through and talk a little bit about the role each one of them play. So the test controller, as I mentioned, is where the tester actually connected to, log in, and run the initiate and control and monitor the test and the test results. The other components in this topology, the test director, the test actors, and the target, they are all passive components, meaning that you don't need to actively connect to those systems in order to do anything on those systems to complete the test. The tests automate the process. It will put the binaries on whether the actors or the target and execute them accordingly, according to the prescribed script or prescribed steps created by the developers of each of the tests. So this is what you would do if you were to test a server, a certified server. As part of it, yes, go ahead.
So you have this HLP compliance. It sounds like that's likely to be a Windows program.
Yes.
So that won't help testing a server, because your server you're already running Windows and your Windows is certified on Windows.
So the question is, what operating system run on all of these systems, yeah?
Yeah.
So
Server, Windows certifies against Windows already, so it's not very interesting to test Windows against Windows.
the goal of the certification here is not Windows against Windows. The question was, what's good is that if all of the components in these topology of the system, in the system of this topology are all running Windows. What good is it to have Windows testing against Windows? The tests are involved here are not for Windows testing against Windows, but it performs Windows testing against the firmware of the system, for example, or Windows testing the hardware implementation, such as the PCI implementation of the system. So the test is not Windows against Windows, but Windows, the OS, against the hardware, the firmware, and the drivers that make up the complete running system. Now, as part of the system certification, you will also be required to test the debuggability of the system for kernel debug. And in order to test that, again, the tester will set up similarly, which is a controller is the initial component, and then the target again. But for the kernel debug, the next part that you would need to set up is a secondary system that would act as both a director and the actor. Now, which will have a kernel debug cable, whether it's a serial port or the Ethernet cable connected to the target. So the role of the test director and test actors are those that coordinate the test sequences, execute the test binaries, and collect the test results and forward the results back to the controller. So you will see these roles being called out consistently throughout this talk, is the controller, the test director, the actor or actors, and then, of course, the target. Now, if you were to use the certification kit to certify a network switch, in this case, the target would be something else completely, not a Windows server, but a device that interacts with a server system. So the target in this case would be the network switch, where the test will execute against the management port of that switch and exercise and validate the manageability implementation of that network switch. So what you would see through these three examples of the topology is that each of the target is a single physical component, a single physical system, a single physical unit, whether that unit is a system or a network switch. What we are evolving for the next version of Windows is changing the way we build out the tests and the way we target. We set up and we validate the target. Today, if you happen to work with the continuous available RAID adapter, you would get to work with something called the cluster in a box test. That test exists today. I don't think anybody in this room would normally work with that because it's a highly specialized product adapter. However, what we are delivering to the partners today is the cluster in a box test, which is allowing the vendors to test a fairly highly complex but very specialized configuration. And the work that we are doing today is to refactor that to make it more generalized and make it more applicable for a wide variety of solutions. And in order to test a cluster in a box, again, you would need the same set of elements: the test controller, the test director, and then the two systems that make up the cluster, the two-node cluster inside a box. Now, the reason the test is called cluster in a box is because there are a number of products being shipped today out there in the marketplace that are actually two systems inside a box. If you look at the Dell Vertex solution or the Violent Memory storage array, each one of those is a two-node cluster. So the test in this kind of configuration, it would go out and it would enumerate the topology and the configuration of the cluster with the storage hardware all wired up. And from there, it will validate that cluster similar to the manner that in the previous talk that you saw how we use various tools and PowerShell commandlets to validate the various cluster. It is the same approach, the same infrastructure that we're using to validate the physical cluster in this case. And once the cluster is validated, it would then construct the actual cluster out of the physical hardware and then execute the tests. So now the target of this validation of these tests is a collection of system and storage together, aggregated, operating as a single unit, as a single logical unit, as opposed to each of the system acting as a separate device or unit. So this is how we are taking something familiar to the test personnel in the ecosystem and evolving them and turning them into something continually familiar, but now be able to operate at a much more complex level when you have to certify and validate a configuration that involves multiple systems, multiple storage elements, and multiple setup configuration that would normally require a high degree of familiarity and technical expertise to do. And we try to do this one and deliver that in a single package through the HLK. Is there any question before we go next to a quick demo of what we are building out? Okay, so let me set this up and ask Ning Yu to come up and walk you through, what the test user experience would be like.
Hello, everyone. Hello? Is it good?
If you turn it on. Yeah, it's turned on. Actually, lower is better. Yeah.
Hello? Is it better now? Hi, my name is Ning Yu He, and I'm one of the developers for this cluster in the box validation kit. And I'm going to give you a quick demo on how the test running experience would look like. Currently, I'm remoted to the WCK controller. So I open the WCK manager. This is the UI interface. And to run this test, we first create a project. Just give it any name. And then we move to selection. Here is our device pool. And if you go to the system tab, it will list all the test machines. So I'm going to select this one as the test director that Sean mentioned. So after select, it will gather the information on this client. And if I go to the test page, it will list all the available tests for this director. And to run the CIB test, we need to first add a feature. And it's under System Fundamental Solution Connected Storage. Check this feature. And now the CIB test will be available. It's showing up here at storage CA test. The test will be need two steps. First, we do the setup, and this test will do the cluster validation. It will verify that the hardware and settings are compatible to failover cluster. And then it will form the cluster. And then it will gather the information about the topology so that the test understand the target under test. So to run this test, we can right-click and select Run Selected. And here we need to pass in the parameters, like the node list is all the cluster node. All the node that's going to form the cluster, and then that's the target we are going to test. And then the domain and username, password, and you also give a unique cluster name, and then click OK. This will perform the test. I'm not going to run this test right now because it will take some time. I'll show you the next step. So because I previously has already run the test, after the test run, there will be a device showing up here. If you go to the Selection and Device Manager tab, you will see there is a cluster control. So this object will be showing up. This is the cluster we just formed against those targets. And then is the step 2. We are running the actual test against this target. So first we need to uncheck this test director, and then go to the device manager and check this device. Now it's showing up as a connected storage device to the test director. And we go, the test should be automatically selected. Like if you go to the test page, the storage state test will be showing up here. And then we just check this and run selected. You can specify how long you would like to run. And this test will it will create SMB share, NFS share, and create iSCSI disks, and launching workload against those disks, and at the same time trigger failover, and the test will do the analysis at the end. This test is still under development. I don't have the test result for this one, but I have the test result for the old test. I can show you how the results look like. So I'm opening the old result. So go to the result page. This is the test we previously run. And here it lists the test steps. First, do some configuration, and then this is the cluster evaluation test. I will show you how the result looks like. Just double-click this TE file, and it will open up here. And we have a bunch of test cases. We run the cluster validation test on inventory, on storage, on network, and on system configuration. And then we form a cluster here. And then we create the SMB share, NFS share, and iSCSI targets. And then doing some failover to make sure this scenario works. And then we're doing some other failover with the I/O going on. And after this test run, we think the cluster settings are good. And the actual, the other test it's running is the reliability test, that we have the workload running, and we trigger failover and we do the measurement. This is a very long logs, and I can show you the final report. So here's how the report look like. We have a couple of criteria to pass or fail the test. First is we check whether the failover happens, and then we check the LAN downtime and how soon it takes for the LAN to back online after failover. And also the failover time seen by the client. That is like the I/O latency during the failover. And also we check if there are any I/O failure or data corruption. So the result is showing in this report. So hopefully this gives you a basic idea like how the multi-system controller labs test running experience looks like.
So I know that the test results is fairly small on the screen to adequately explain and show you what it looks like. And we will be here, staying here, and I can walk you through, Ningyu and I can walk you through the detail of the test if you're interested. But I want to recap on a couple of important points, was that as we are going forward, we want to shift our focus from providing the tests that targeting individual single component. We're shifting from that over to the solution type of configuration. And the solution could be as simple as, well, quote unquote, as simple as a cluster in a box with storage and system components, or as in the next talk by Vipin, we are going to talk about a solution that is as complex as what we refer to as a private cloud. And our goal is to deliver these kind of tests to you, our partners, so that you could collaborate with us and validate your solutions, your products, how each one of them play in those solutions, and give the customers a great experience as they take delivery of those solutions in their own environment. Okay, so we're going to go ahead and switch speakers, and let our next, the Hyper-V team, talk about the private cloud simulator.